Make a table of values just as practice here. So you're talking about incrementing, so you have your theta value, so you have r equals 1 minus cosine theta. So you have your theta value and your r value. So what's a good theta value to start with? 0. Plug in 0. What's cosine of 0? 1. Yeah, it's the r is 0. That's correct, okay? So like we could have theta value, I don't know, pi over 4, pi over 3, pi over 2. You could plug these in. What's cosine of pi over 4? So it's going to be 1 minus root 2 over 2. Girls, shh. 1 minus what? Root 3 over 2 and 1 minus what? 1 minus 0. Yeah, so then you plot these points. If you want to plot these points, let's just plot these just to do a few of them. Theta value of 0 and the r value is 0. So where are we?
The origin.
We're at the origin. So we're at the origin right there. And then we're at pi over 4, which is how many degrees? It really shouldn't be a thought stumper to ask you how many degrees is pi over 4. Pi over 4 is how many degrees? 45. So we're at 45 degrees. And what distance? 1 minus root 2 over 2. This is where the decimals come into play. It's kind of annoying. Root 2 is what? 1 point what? 414, right? 1.414, 1.414 over 2. It's like, you know, so it's like a little bit over a quarter for this, right? The point is, if let's just say we set this as 1, how far are we going to be away? We're going to be like, I don't know, like this far away? Something like that?
No, wait, if it was minus
1 minus 1.414 over 2, right, is going to be about what?
0.3.
About 0.3, so maybe it's a little bit further. Great, it's a little bit further. It's like there, nice. So there's the second point. And then you have 1 minus, and then 60 degrees. You're at this angle right there, and then it's 1 minus root 3 over 2. Root 3 over 2, is that greater than or less than 1?
Root 3 over 2 is less than 1.
Less than 1, so where's it going to go? So where's that point going to be roughly? Describe for me where it's going to I will repeat that, everybody. So, girls, over on the side, let's just be a little quieter. So you have this nice thing right here. This right here is an expression for a region, the area of a region. The formula we have is, from yesterday, 1/2 alpha to beta of r theta squared times d theta. That is the area under the polar curve. In terms of under, it means towards the origin. Towards the origin. We had those sectors we swept out yesterday, the sectors we swept out. So in terms of this formula right here, what is r theta? Sine of 3 theta. R theta is being squared here for this formula, for the area of the sector. But what's the area of the sector? 1/2 r squared theta. 1/2 r squared theta. So in this case, we have 1/2 the integral from alpha to beta of, there's r squared d theta, because it's infinitesimally small slices. So the function we're doing the area of is 3 theta, and we're going from 0 to pi over 3. So when we do this on our calculator, the window's a little big here. So what should we change this to? How about negative, what should we do? Negative, what, 1 to 1? Something like that? Or is that too small or too big? What do we think? Oh, just right. Excellent. Nice. So we have this, right? Ugh, that's not helpful. Did it get like the intro layer? Yeah, it got the weird like intermediary layer. It's not. Stop it. Cancel. New. There we go. So we have our function right here. Did you actually graph that by hand, Caroline?
Well, you only should do the
First like quadrant?
Yeah, because it was just
It's just from origin to origin?
yeah.
Got it. Okay. So when you have this right here, it's asking, this is the region you're doing, right? I think? 0 to pi over 3. And how do you know it's pi over 3? You can kind of see it because you have 0 degrees, right? And then what's the degree angle? Oh, it comes back and like, what degree angle does this look like right here? It's 60. It's going to 60 as it gets it. This is not square, so it's hard to see. Like, do you know about that zoom window feature?
Yeah.
So what is it? Zoom, what is it?
Zoom to
Or is it, that's square. We change it to square. You see how it looks a little bit more like 60 on the approach right here? 60 degrees. Does that make sense? Yes, Caroline.
r squared and d theta.
R squared theta, d theta. Exactly. So first things first, we need, well, it depends. We can start in a few places. What do you notice about the, let's just shade the region we're trying to find the area. We're trying to find this area, right? And what else? The lower one, right? What do you notice about those two areas?
They're symmetrical.
So what could we do instead of finding both? We could just do 2 times one of them, right? So we could do 2 times one of them. So we'll put a 2 out front and just do maybe the top one. Okay, so the question now is, I'll do the order here. What's the alpha and what's the beta? What's the alpha for the upper region?
0.
It is 0. So we have 2, and I'm going to keep this up there just so you can remember that they're there. It's going to be 2 times 1/2 of 0 to what? Because instead of doing both of these, we're going to find just this area right here and multiply it times 2 to get both. So it's 2 times, the original one is 1/2. We're putting the 2 there because we're just going to do the upper one. With me?
Yeah.
So it's 0 to what? Yeah, 0 to pi. You have to be super careful about this. So if we're starting here, to get all of these points right here, this point, this point, this point, this point, you have to go all the way around. What angle measure is going to be right here? Yeah, that's pretty cool, huh? Yeah. So 0 all the way to, there's a big magnet in this thing. So 0 to pi. Are we okay so far? Are we okay so far? I love what impresses you, by the way. It's pretty cool. So now the real question is, what's going to go in here? You have to be super careful about this. What's going to go inside the integral?
That thing minus
That thing. Can we be more specific?
2 cosine theta.
So it's going to be what?
2 cosine
2 cosine theta. We have to do something to that.
minus.
It's 1 plus.
We have to square this thing, right?
I have to square this thing, right? Do we square them individually, or do we...
I think you squared them individually and subtracted.
Individually. You've done things like this before in regular Cartesian integrals, right? It's a really common mistake. So we should square each one, say it again? Individually. Because what we're really doing is 2 integrals. We're doing the bigger one, and we're subtracting out the inner one. So it's the outer one in this case, the red one. So it's what's going to go in the other blank, Pinky?